for the given circuit we need to find what is the value of RL that will result in 3 milliwatt power dissipated by this one, which is the maximum power delivered to it. So we have to find the value of RL. Now this side we can imagine this side to be the source side, which has 3 voltage sources though, and this is also line. There are 3 line resistances in like this combination. Now we need to find what is the value of RL which will result in maximum power delivered to it, and the maximum power is given, which is 3 milliwatt. So I have to do something here. So what I will start doing by is, I can see there are 3 voltage sources and each of them has this resistance in series with it. Now it's better if we could find one source here and one resistance here, which is hard with this combination. So I will convert this voltage source and the series resistance into a current source and a parallel resistance. We can do that because this side will not be affected and we are just interested about this side. So whatever changes here, we do not need the current through each of the resistances or anything, so we can do the change. So let's do that. The current source polarity will be like this, and once we have like this, we will be able to, since current source and parallel resistance, we will be able to add the current sources, which we can't do at this point. We can't add the voltage sources or do anything with this combination. So here it's like that. So the resistances value will be the same. There's one more resistance here, which is R, and then our RL, which we need to find out, RL. So the value of the resistances now will be voltage, the current sources will be the voltage source divided by the resistance. So this is 1 volts and divided by R. This one will be 2 because it was 2 volts divided by R, and this one will be 3 divided by R. Now we can add up, the current sources are in the same direction, so we can just add them up, and also we can find the parallel combination of the resistances. So if I add up the current sources, so then we will have just one current source and one parallel resistance. So that will be, if we add these 3 current sources up, it will be 5 over R, and then here the resistances will be same value but 3 of them in parallel, so it will be just R by 3. And of course, what is the value of RL? Because RL will have, we have the power and we also know this is the maximum power delivered to it. So of course the line resistance and this resistance will be the same, so it will be R by 3. The load resistance, which is the RL, will be R by 3. So we know that now. Now we can convert this part into a voltage source and a series resistance, but we actually don't have to do that, but I will do that with the conversion afterwards. But now we will just find with the given arrangement. So we have, this is the current. Actually 1 plus 2 plus 3, it will be 6, not 5, sorry. So 6 over R, that's the value of the current source. Now this current will, once it comes at this node, it will be divided between two same resistance, same value resistances. So of course the current through RL will be just half of that, so it will be 3 over R. So we have the current through RL and we know the power that is it's dissipating. So PRL is 3 milliwatt, it is given, and current through RL is 3 over R I square times R, which is R over 3. So that's the power. Now we know this power, that will be 9 over R square times R over 3. So that will be 3 here and then 1 over R. Actually this will be 3. So R will become 1. Now this value will be in kilo ohms because the power is in milliwatt. So this will be kilo ohms. So that's the resistance. We find the value of the resistance. Now I will do the same problem with converting into a voltage source and a parallel resistance, series resistance. So like that. So of course the value of the resistance will be the same, and the value of the source will be 6 over R times R over 3. So that will be 2. So 2 here. So the current now is, let's find the current, will be the voltage divided by sum of the resistances since they are in series. So that will be 2R over 3. So that is actually 3 over R. So we are getting basically the same current. Of course it would be, but I have just done it with the voltage source and a series resistance, which is more like a source and a line, but that's okay. This is also the same. So basically now if I do it, it will be the same thing, because PRL will be I square R. So I square is 3 over R square over R over 3, and we will get the same result. I'm not doing it anymore because that was the same expression which we got here. So that's the value of the resistance R for the given circuit. RL basically. So yeah, sorry, that's the value of R, and if we want to find RL, the RL will be R over 3, so that will be 1 over 3, so 0.33 kilo ohms or 330 ohms resistance. So that's there, and the value of R is 1 kilo ohms.